second topic of the course. And again, all of the links are on our website. So make sure if you want to view them at the same view the slide or like the demos we're doing along the way, feel free to do so. And I would just mention that this lecture, the second topic here, many of the material, you probably have seen it already because the lab happened last week, only after first lecture. So this, like I said, we will do it relatively quickly, but definitely make sure to stop me whenever you have questions. And we'll just now sort of like overview of Python programming and some of the key terminologies, and then how to do certain things with Jupyter Notebook. Okay. And like I said, some of you, everybody I should say, that have seen Jupyter Notebooks here and there and how to do it. So many of this might not sound very new, but regardless, I think it's very important to go over certain topics in detail. So we're able to make sure that we know the terminology and we know why Python works in the way that we have seen in the lab. All right, so the Python programming language, okay, it is popular. Okay, now you probably know it, or maybe that's one of the reasons why you sign up for this course. And it's pretty popular, especially now for data science. And if you have taken some other statistics course in the past, then you probably know about the other programming language called R. Okay, so both of them are free. Okay, and it's open source, meaning that people actually can write packages themselves and then share it widely online. So that's actually one reason I think those open source programming languages are becoming ever more popular and widely used. Okay, but Python is also very good for general software development. Okay. Whereas R, I would say, mostly is for data science and statistics. Okay, and so we hopefully you'll be able to master the language fundamentals, especially as soon as you can in this course. And later on, you'll be able to learn a lot more other functionalities. Okay, and we're also going to highlight, and I think everybody probably know this now after the first lab, is that we're going to learn through practice. Okay, not just by reading the code or listening to me or Jason talking to you about this. And a lot of times you learn by mistakes as well. Okay, so definitely feel free to reach out whenever you run into issues, but also take the chances of those mistakes or challenging questions. They're really good learning opportunities for you to get to know Python, as well as, I should also mention, actually, once you get more fluent, everybody has their own programming style. Okay, so maybe some of you like writing functions in this particular way. Some people were like writing functions in that particular way. So you will also gradually develop your own style. And I think there's no like better or worse or wrong or correct. There's really just, I should say, as long as they're correct, there's nothing like better or worse. But I think it will take practice for sure. And then I would definitely encourage you all to develop the programming style that you like and feel comfortable. Okay. So the demo we're going to do is, if you go to our website, okay, the first one is called Python expressions. Okay, so you can click it and it should bring you to that Jupyter Notebook for this particular case as well. Okay, so I'm going to do a demo. And I think, like I said, many of you have seen this already in the lab. So this will be relatively quick, but they are quite important to talk through as well. Okay, so first of all, I think by now you know, okay, and we put a words of caution at the beginning to make sure that you always need to run the first cell where you're loading the data science library for this course. Okay, so remember to do it, to run any cell, you can either click run up here, okay, and then you will see a little star, and then once it's done, like it's gonna be like the index of which index of the cell being run. Okay, so you can click run and you can do it multiple times. Now it becomes 2. Okay, if you do it one more time, it's 3. Okay, and so that's one way to run it. And the other one, maybe some of you are familiar with it now. If you push shift and enter, it's going to run the cell for you as well. Okay. All right. So for this particular demo, we're looking at Python expressions. Okay. And all of the examples, as you see, even before I run it, I think you will see that we're really using Python as a calculator at this point. Okay. We can do summation. Okay. Multiplication, division. Okay. And then this is multiplication and then addition. Okay. And then, well, the rules of Python, using Python as a calculator, as you can see here, it really also just follows the arithmetic rules that you do it by hand. Okay, so multiplication comes before addition. So even if I add the parentheses here, it doesn't really matter because it should be the same order. Okay, you always do the multiplication first and then the addition. However, now we know, right, if you put parentheses and in the addition first, so that would go first and then the multiplication. However, the results here is the same because we're really doing the same calculation, okay? The last one, I think many of you have seen that in your lab because one of the exercises I remember is about this, is the power, okay? So if I want to do 2 times 2 times 2, of course, I can do 2 times 2 times 2 as the one that we, by the way, the pound sound here, the sign, this is commented out, so we're not running it, okay? But if you want to run it, oh, by the way, you can always add a cell if you look at the top, okay? The user notebook is your own, so you can do any kind of changes if you want. So if I do all of this, right? And if I run it, it's gonna be 8, we know that. But then it will be the same as putting 2 stars next to each other, and this is power, okay? So 2 to the power of 3 is 8 as well, okay? So this is, again, we're really using Python as a calculator at this point, but you can see that it's pretty flexible and then it operates in the way just like a regular calculator that you would do. All right, so that's for a quick overview. And now the second topic of tables is names. Okay, so this, I think some of you have seen it as well in the lab. Okay, so this is getting to see Python really as a programming language. Okay, earlier is really just a calculator, but we can also assign expressions to names that we are able to use later. Okay, so the assignment statement, okay, we are doing the anatomy over here. Okay, so hours underscore per underscore week. Okay, that's the name. Okay, you can think of it as an object. Okay, and that goes before the equation sign. Okay, on the right hand side is an expression. Okay, for us, well, hours per week, as you can see over here, well, you can actually calculate it. And if we know, so by the way, this is also a good example of choosing your name as informative as possible. Okay, so here we're talking about hours per week, and we know that, well, 24 times 7, okay, that will be the hours per week if we actually want to calculate it correctly. But then again, on the right hand side can be an expression. In this case, we're just showing you in the definition itself. So this kind of statements, they do not have a value. Okay, they really just perform an action. So that equality, that equation sign, equal over here, is assignment. Okay, it's not saying that hours per week equals to that, even though, well, intuitively you would think so, but you can apply it to any other expression on the right-hand side, okay? But the whole thing is really just perform an action, okay? An assignment statement changes the meaning of the name to the left of the, changes the meaning of the name to the left of the equal symbol, okay? And of course, the name is bound to a value. It's not an equation. Okay, it's a value. So once I run this line, as you can see, that once I do 24 times 7, which I think is 168, right? 168, then we assign that value to hours per week. Okay, so the assignment statements, I think we have seen this again, I think multiple times in that lab. And just to not to like duplicate, but you know that we really learn by practice. I'm just going to show you how to do various names and then give you some examples to make sure that we understand how names really work. So just like before, okay, make sure that you run the first line, which is loading the library to our workspace, okay? All right, so the first one, we assign 6 to A. A is the name, okay? So after running this, nothing changes, okay? We don't have an output or anything. But we know that after we round that A equals to 6, we have done the assignment of assigning 6 to A. Okay? So if now I just try to type A, which is returning the value of A, then it gives me a 6. Okay? Similarly, this line assigns 4 to B, and if I just return the value of B, it's 4. Okay? So now, starting from now, you will start to see why we do want to have this kind of naming as well as assignment, because once we have assigned values to certain object, which we have a name for, then we're able to do many other things about those objects, okay? So for example, the total, now we define, so total again goes before the equal symbol. Okay, so this again is the name. Okay, and then on the right hand side, we're doing addition. Okay, and in particular, we're doing the addition not directly with 6 and 4 anymore. We're actually doing A plus B. So meaning that whatever is stored in A and whatever is stored in B, after we run this total equal A plus B line, we're adding whatever is stored in A with that stored in B. Okay, so we know here the total, right, will be 10, okay? Because 6 plus 4 is 10, okay? But let me just show you one more thing. So let's just say here, okay, instead of, let me just add them so we don't get confused. Okay, so now, instead of 4, let me just say that I want my B to be 3. Okay? If I round this, okay, now I'm gonna run total. What do you think after I run this, the total should be? Feel free to speak up or just type in the chat based on your understanding of how Python works with the names now.
It would be 9, right?
Okay, so we got one answer to be 9. Everybody agrees? I see chat.
Wouldn't it still be 10?
Okay, another question. Another comment is 10. Okay, and then Matthew in the chat also says 10. Okay, so this is I guess I asked a good question here. Okay, yeah, so up until here, if you see this, okay, total is A plus B. Okay, and up until here, we know that A is 6, B is 4. So the total as we have run it here is 10. Okay. Now what we did, we changed the value assigned to B. Okay, so if I run this, I run it already, I guess. So if I actually just return B, it's going to be 3. Okay, and total we know is A plus B. However, unless we run this A plus B one more time to assign it to total, this total won't change. Okay, so let me show you. So if we do this here, it will still be 10 because when we round the total line, when we assign total with A plus B, back then the value of A is 6 and the value of B is 10 is 4. Okay, so total will be 10 at that point. However, if now I add this line, I repeat this line one more time, total equals to A plus B, and I run this, okay? And if I run it again, now it should be 9. Okay? So this is what we mean by assignment, okay? The value of the name that we're doing, the expression over here, it will change after you run it, but the issue back here is that the total, we only run it when B equals to 4. We had not rerun it, even if we have reassigned the value of B. Okay? So if we don't do that, then you will see that the total will still be 10, even though B becomes 3. But now I reassign A and B, the sum of A and B to total again. So here at this point, B is 3, right? And A is 6. So once we do this new assignment, the newly assigned total will become 9. Okay? So this is, again, why we say that it's not really just a calculator now, because we're actually working with those names, right? We're having those objects with names and we can assign values to them. And then this will start to play so many different roles in all of the programming that we're going to see upcoming.
I have a question.
Yes, go ahead.
So you know how you rewrote the total again, you wrote A plus B after updating it. What if you just ran the original total again without?
Oh yeah, no, that's a great point. Okay, so I could have done that as well. So for example, okay, because I already did everything. So let me actually, okay. So so the answer to that question will be that yes, we're gonna get the same thing. But for me, I just rewrote it just to make sure that it's not confusing. But let me reproduce what Anthony was saying. Okay, so A, B, everything is good, right? The total here is 10, okay? And now if I do B, okay, and my B here is 3, right? If I run total now, it's still gonna be 10 because nothing changes. But instead of doing the total again down here, I can actually come back to this one, okay? And that's why actually Jupyter Notebook is really useful because it tells you the index of the order, okay, of the cells being run. So if I come back up here, I run this again, this becomes 11, okay? And then running this here or here is equivalent, okay? because I'm essentially just reassign A and B, the sum of it, to total. So I run this as the line 11 here. And if I do it, this is going to become 9. Okay. So
Gotcha, thank you.
yeah, makes sense? Yeah, so I would definitely recommend, I mean, I guess either way will work. But I do remember, I think there was one question from lab last week that sometimes it's very easy to say, for example, like you're working on one problem and then maybe you got stuck, but then you continue working on the other ones. And then when you revisit, if it happens that the later sections of the code actually redefine some of the values for the previous question, then you're going to start to get into trouble. Okay. So I guess, again, this is a style thing. Like, I guess I unconsciously think that I'm going to rerun this like with new lines just to make sure that I don't get stuck later. But really, it's the same thing. And meaning that you can always come back to rerun the line, and then the indexing in the bracket next to it is going to tell you about it. But overall, I think if you want to avoid getting stuck later about those different assignments, it's probably always good to start a new line of your new code and then run it in the order of the way that it's written. So later you will be easier for you to navigate across the post-its. Okay. All right. So the couple of other examples here. Okay. So earlier we were doing assignment and addition. Okay. And now let's try to do multiplication. Okay. Length is 4, length is 6, width is 4. So if it's a rectangle area, we know it's the multiplication of the 2. So if we do that, and then we know that this becomes 24. Okay. And this is actually another example. Okay. If now I switch my width to 5 instead of 4, so the rectangular area up until this point, if I run it, will still be 24. Okay, because I have not done the assignment one more time. Okay, so it's still going to be 24. However, now I reassign rectangle area with length and width, and we know that now length will still be 6. Okay, but width will be what we just assigned, which to be 5. So here, here will be 30. So hopefully these two examples can illustrate to some degree about how the assignment is working, and then the order of the running of the code. And we also just discussed like whether we can go back to the previous line and run it, and we can see that you can, but always make sure that you know the order, because otherwise sometimes it might get a little bit confusing. The last section here is, well, you might be wondering why use names, okay? And as we go along the semester, I think it's going to becoming more and more obvious why we want to do it. But even now, I think we can do some quick demos. So let's just see, let's just say here, hours per week is, well, work hours per week. Let's just do 8 times 5, which is 40. And the weeks per year, 52, okay? So if I do that, well, if I assign 40 to hours per week, 52 to weeks per year, and then if I want to compute, right, the number or the hours, work hours per year that I'm doing, I'm really just multiplying this 2. Okay? And then I can assign it to this new hours per year. So this is again an example of showing, I guess, the importance of naming your objects like informatively, because later you know exactly what you're doing. Okay, so when we do this, it's going to be a multiplication. It's 2080. Okay, and now you know the total hours per year that you'll be able to do for this particular case. And let's just say the New York hourly minimum wage is $11.8. Okay, so we assign 11.8 to this object called NY hourly minimum wage. And if we do that, then we can actually get the monthly wages, okay, which is hours per week times the hourly minimum wage, which is 472. And just as I'm doing this, I guess we probably, no, this is actually a bad example of using a non-informative variable name. I think this one should really be weekly wages, right? Because we're doing what? Hours per week times minimum week, hourly minimum wage. So we should really call it like weekly wages. Sorry about that. And the yearly wages, we know that's going to be hours per year times the minimum hourly wage. So if you do this, okay, that will give you those numbers. Okay. And of course, well, let me do 11.8 if you don't want to go with all of the stuff that we had done, you can always just type those values, right? Using Python as a calculator, that will give you the same answer for sure. But then what if later you want to use this objects, like later I want to use hours per week for some other purposes. And then it's always much better if you're able to name it beforehand. So later you can use it at your convenience. Okay, so these are maybe toy examples, maybe not as relevant as you see right now, but like I said, as we go along the semester, I think it will become more important and obvious to you that we really want to use informative names and correct names. So that example here should be weekly wages just now, not monthly, because we're only hours per week to multiply with the minimum wage. Okay, and eventually you're really using it as a you can always use it as a calculator, but more efficiently you want to use those names informatively, and then later you are able to revisit them whenever you need. Okay. Quick question here. Comments, concerns? Okay. Yeah, okay, good. Like I said, many of this are shown to you, I think, in our lab, so maybe not so much new, but it's good to see them multiple times, like I said. Alrighty, okay. So the next, I should say, topic here is call expressions or functions. Okay, we have seen it in the lab, but let me show you, give you anatomy here of what we mean by call expressions, what kind of thing it takes, and what kind of output it will give. So anatomy of a call expression, okay, so F, we use it generically now. F, we can think of as any, any function. We just use F to stands for function, okay, it's the name of the function, okay. And in Python, okay, you have the name of the function, and then you put a parenthesis, and inside the function is the argument what we put into the function. Okay, so F27 at this point probably doesn't mean anything to you or to me, but really we just want to show you that the function name goes first, and then you put a parenthesis, and whatever arguments that is needed, you should go into the parenthesis. And this example, as you can see, that we only have one argument, but it depends on the function that you're working with. You could put in multiple arguments. So you can call this as call F on 27. Whatever F is going to be applied to 27. Okay. So for example, mathematically, let's just say the F function is dividing whatever argument by 3. So then if I apply F, I call F on 27, and if F itself is dividing the argument, the input by 3, then the outcome of this is going to be 27 divided by 3, which is 9. Okay, so really, like you said, you see over here, the function itself depends on what the function is about. You will see what the outcome is. Okay? So let me show you another one, which is more realistic. And I think some of you have seen this in the lab already. So this is a function or call expression we call max. Okay, so max again is the name of the function. Okay, so we type that first. Okay, and then you will have input go into this function. And actually, in this case, we have 2 arguments, the first and the second. Okay, and we know that mathematically the max is taking the maximum over the 2 if we're having 2 arguments, right? So the output of this is going to be 27. Okay. If my function is called min, which is actually also available in Python, which is min, okay? If you do min 15 and 27, then it's returning the minimum, so it's going to be 15. Okay, so this is anatomy of a call expression, in particular for the max function. And let's look at some other examples that we might encounter in this course. Okay. Always important, run the first line, so we load the library, okay? So the first one is the absolute value, okay? And we call it ABS, okay? So we know that in mathematics, absolute value will just give you, like, if it's negative value, you take out of the negative sign, right? So it's really just like the positive part of any value that you're doing. So absolute value of -5 is going to be 5. Okay, so ABS is the name of the function, and it has 1 input argument. And it's going to be applying the ABS function on -5, which gives us 5. Okay, so if we come back to what we did before, even though maybe absolute value of the difference of this 2 doesn't really make sense, like in the physical world, but we can still run it. So sometimes you see if the server is a bit slow, you will see that we have to wait until it's done. I'm not too sure why exactly it's taking longer to run this length equals to 6. This should be overall straightforward. So maybe something is not entirely good with the server right now. That's why it's taking a long time. So let's just maybe wait until it's done. But if we round this line, absolute value of length minus width, what do you think the answer is going to be? Okay, it's going to be 2. Okay. Oh, yeah. I guess it's my internet was unstable just now. Thanks for all the chats. I only saw it. Oh, thanks. Okay, I was frozen. Sorry about that. And I think now I'm back and everybody's moving. So I think, okay, sounds good. So it's 2. And like I said, maybe it doesn't have any physical meaning, like the length minus width, take the absolute value, but still you're able to do that kind of calculation. Okay. So minimum of 14 and 15, we know that's going to be 14. Okay. And this is the example of the min function that I was talking about. Another useful function for us to use in this course is the round. Okay, so round, as you could guess the name from it, it's like rounding a value to its nearest integer. Okay, so if I have 123.456, if I run it, it's just going to be 1, 2, 3. Okay, but you can also see that the round function actually could have more than one input. Okay, so earlier we only have the input of the value that we want to round, right? But another option here is to how many digits we want to round it. Okay, so by default, it's going to be rounding to the nearest integer. Okay, but you can choose 1, which is going to give you, I think, 1 digit. Okay, and if you want, we can try out with 2 digits, and then it's going to round it to 2 digits. Okay, so round is actually an interesting function among the ones that we have seen so far, right? Like there's a default second input, I think, which probably is 0. Yeah, right. So the default is 0. Okay, if we don't type it, the default is 0, so it's always going to round it to the integer. Okay, but if we do 1, 2, then we're able to control to how many digits we want to do the rounding. Okay. So I think throughout the semester, we learn so many other functions that are available out there in Python. But I should also mention that soonish, I think maybe 1/3 of the semester, once we get through the 1/3 of the semester, I think you will be started writing your own function. Okay, you're able to write your own function depending what kind of purpose that you have this function for. And then you're able to, as you can see, well, not now, because those functions, I guess we don't know how they're written, but as we start to write our own functions, you will see that where you're going to have the input, how you're like in the bulk of the function, how you are allowing those inputs to interact with each other. And then in the end, you have a return argument in the end that is going to return whatever is to you. Okay, so those will become very useful, and I hope you will enjoy when we get to that point. So the last topic of this topic is tables. Finally, I mean, the topic is about tables. So now we're ready to talk about tables. And then since this is a data science course, we're going to deal with data set a lot. Okay, so that's why actually the data science library that we're introducing here for this course, they have a pretty comprehensive list of functions to deal with tables. Okay, so tables, as you will see now, we define tables to be data tables. Okay. Data tables meaning that, well, we're going to have each row to represent a observation or individual, okay? And each column is what we call like a label, okay? And it's talking about, well, whatever information that you're coding for each of the variables, for each of the individual, okay? So in this particular table, we have, well, the first row is always like the name of the columns or the name of the labels, okay? So, but then the number of rows, like the actual data rows here is 2. We have California and Nevada. So the name column is the first column, is the name of the state. Okay. The second column on label is called code. Okay, that's just the abbreviation for each state. Okay, and the third column or label is area in square meters. Okay, So data, like we usually gonna represent a data set as a table structure like what we're seeing right now. Okay, you will see that we have rows, we have columns, okay? And each row represent an individual or observation. Each column is representing an attribute, or sometimes we call it variable of the individuals. And let's do a demo. So you see what we need. We're gonna bring in two examples, two data sets, and then we're able to do all kinds of manipulation with them. Okay, so always make sure to run the first line. Okay, it is loading the library. Okay, the first table that we're going to introduce is the cones. Okay, it's saved in the CSV format, and then the table, capital T table dot read underscore table is reading a CSV file into a table. Okay, so this part of the code is showing us is reading the table, and notice here we assign it into a object called cones. Okay, so this is only reading it, but you want to assign it to some object that later we can access. Okay, so this first line altogether is showing the entire process. Okay, so let me run this, and I'm printing the cones. Okay, so you will see that it's going to print it out. Okay. The difference, so let me actually just add one more cell over here. If I only just read it, but I do not assign it anywhere, I'm only going to read it, but it's not assigned to anything like an object that called cones. So if we only when we assign it to something that we're able to access later. Okay? Otherwise, we're really just reading the table and printing it out. So the most useful way to read the table is read it as well as assign it to our object, and you name it. In this case, we name it as cones. Okay, just, well, that's the name of the data set, so we can go with it, but we can go with anything, okay? All right, so the data table, let's see, how many columns are here? 3, okay, sounds good. And the first one is about the flavor, second is about the color, third one is the price, okay? The rows is 1, 2, 3, 4, 5, 6. Okay, so there's 6 individuals or observations, okay? Each of them, we have information about the flavor, the color, and the price in dollars. Okay. All right. So let me show you some very important and interesting functions of the table object. Okay. So cones right now is a table. Okay, because we assign it, and we first read the table and then assign it to cones. So there are so many different functionalities of tables in this data science library. The first one, as you can see, is show. Okay, and you see that to access that, we type the name of the data table, it's called cones, right? And then we put a dot, and then we use the name, which is show, and then we put in the parentheses 3, meaning that we're going to show the first 3 rows. Okay, so once we do that, you will see that only the first 3 are printed out, but it's going to also show you that 3 rows are omitted. Okay? So by this, you know that there should be 6. Okay, you can also just show all of them. So if you do show and then put nothing in the parentheses, it's going to show the entire thing. Okay? So this is slightly, I guess, well, from the output, it's the same as just like typing cones and run it, right? But then cones is really just like printing out, whereas show, I think, is specifically asking it to show it. I guess, like I said, the outcome is the same, it's showing the entire table, but the show can be more flexible by choosing a particular number of rows that you want to print. So just notice the way that we're using it. We, first of all, we are working on the table called cones, okay? And the function is called show. So we do cones dot show, and then in the parentheses, depending on how many rows we want to print, or all of them. So get familiar with the feature, or like how the syntax is, because now we're getting to a second function that we're able to apply to a table. Notice again, we're using cones, okay? That's the name of the table, and we use dot, okay? And the function called select. Okay? And then you can see here in the parentheses, we do quote flavor. So what do you think? If you were to guess, what do you think this line, after I run this, what do you think the printout is going to be? And from that, what do you think the select function is doing to my tables? If you were to guess, what do you think that would be? Okay, I see. Okay, let me bring up the chat. And feel free to just to speak up. Only the flavor column. Thank you, Samantha. So let me try to do that. Okay. Okay, so this is one and other use of a function called select. Okay, and you can select flavor as a column. Okay, and then the printout will be a whole column. Okay. So now I guess you will be able to guess, well, if I select two columns, what we're going to do, we're going to return table with two columns. Okay, the column of flavor and the column of color. Okay. And notice the outcome, like the printout is the table again. Okay, so if I want to actually have a reduced table of only the column of flavor and the column of color, maybe I will call it like cones underscore flavor and color and assign it to it. Then I will be able to access my new table later. Okay. For now, we're just really demonstrating the choice, the use of select, the function. So we're just printing it out. But if you want to use it later, you want to assign it to something, and then you can access it. Okay. That's a good practice if you really need it. Okay. All right. Now the second, guess here, cones.drop, and then parenthesis quote color. What do you think this is going to do? Any guess?
It doesn't print the column that you name.
So remember, color is one of the columns, right? We have three columns, okay? So if now we drop it, okay, you will see that, well, the entire column of color is being dropped from my original table. Okay, so select is selecting the ones that you want to keep or like maybe you want to use later, and drop is actually to drop the column that you don't want. Okay. Now my next question for you is that now if I want to print my cones again, how many columns are left? I've done so many things now. Okay, I have selected one, flavor. I've selected two columns, flavor and color. I've also done some dropping here of color. What my cone's going to be now after all of this manipulations?
Still going to be the same original table.
Because?
Oh, did you ask why?
Oh yeah. What do you think? Why?
Oh, yeah, because we didn't like change the name. It's still cones from the original definition.
Yeah, exactly. So that's what I was saying earlier. If we want to select and then access it later, we have to assign this whole function or expression into something. Otherwise, we're not changing cones at all. Okay, so now let's run cones. And we still have our original three columns. Every observation is there. Okay, so this might be a little bit surprising at the beginning, but as you work on more examples, I'm sure you'll get used to it. But let me just warn you up front, I think it's still the most common mistakes people make later on as well. Okay, so get used to it. I'm sure more practice will help you a lot. All right, so if I really want to have no color column at all, then I should really do what I'm highlighting now. Okay, remember on the right hand side, I have dropped the column, color column. Okay, but at the same time, I have assigned it to a new object called cones no color. Okay. Now I have assigned it to an object, and if I print that object out, then this particular object finally will have no color because I have dropped it and I have signed it. Okay. But of course, if we now again type cones, so let me just add a column, add a cell here. If I do cones again, cones never change. Okay, I never really touched it. I do many things on it, but I don't change it. But if I assign it to something else, like cones no color, well, the name, as you can tell, does not have the color column anymore, then that is where we have made the change. Okay. And I should maybe not even say that this is a change. This is really just, I never really changed cones. Okay. And now just assign it to something else that, well, later I will be able to use. Okay. All right. A couple of more functions, and then we're going to end today. The first one is where. This is super useful. You can see that, well, again, it's cones.where. Okay, where is the function? Okay, so where, as you can see, is that we're trying to find the flavor, which is chocolate. Okay, so that's how you read this this line. Okay, so what that means is that, so now you can see that the where function has two inputs, right? The first one is the column name or the label name. The second one is the value of that name that you're looking for. Okay? So if I run this, what do you think I will get? I will probably get 3 rows, right? I will, because I'm searching for, where is searching, you can think of like trying to select. I'm selecting the flavor, which is chocolate. And if I look at my original Combs database, like data table, I have 3 rows, that is chocolate flavor, right? So if I do that, it's going to give me all of the chocolate flavor and then their associated color and price. Okay? So you can call this subsetting or subset. Okay? And notice how the where function is being used here. You will have to first get the input of the column name or label name, which is flavor. Okay? And then the second input is the value that you're looking for that column. Okay? So really quick over here, what if I want to select all of the rows with color pink? What should I do? You can just speak up. Anyone? I do cones, right? Mm-hmm.
Cones dot where color and what? Wait, which color?
What did I say? Pink. Let's just say pink.
Pink.
Okay. So now it's pink. Okay. Yeah. So first input, thanks. First input is color. Okay. Second input is pink. And make sure that you're spelling it exactly the way to spell, like capital letter, small letter, make sure it's the same. So if we run that, well, we're going to get 3 rows again because there are 3 pink colors. Okay. All right. So the last one I want to show you is sort. Okay. And by the name, I guess it's informative enough what it's doing. Okay. And in particular, we're sorting the column price. Okay. So this is sorting. Usually is being done to a continuous variable like price. So if we do that, well, we're sorting from the lowest price to the highest price. Okay. And then of course, this is another example of, well, if you don't supply the second, let's see, if you don't select the second input, it's gonna be ascending because by default. But you can always put the second input, say, I want to do it from highest to lowest. Then I can do descending equals to true, and I'm sorting in that way. The highest, so the most expensive from the top to the least expensive to the bottom. Okay. And most likely, like I said, I think this kind of sorting makes most sense for numerical variables like price. But I think you can also sort other things if you want. And I guess here, if we're going to sort by flavor, and I guess descending or ascending in this case is really, I guess in this case, just showing alphabetically the first letter of that. In this case, if I'm doing descending for true for flavor, then I'm going to show strawberry first because S is last, okay, and chocolate and then bubblegum. Okay. Yeah, so in the same demo, there's one other like demo that maybe you can try it before we meet on Thursday. But I think on Thursday when we come back, we're gonna revisit those important functions of table and then do one more demo with an MBA salaries from 2015 to 2016 student data set, and then do where, as you can see, and then sort and descending and show. And there's one other thing called relabel. Okay, if you don't like the name of one variable, you can relabel it to something else. And that's another function that is really useful later on. Okay. All right. So I think that's all for today. And any questions, comments? And I know some of you need to do the, couldn't get on Slack, so you can feel free to stay over. I will walk you through to make sure that everything has, everything seems right. And any comments, questions? Okay, yeah, Anthony, I saw that. Okay, sounds good. So, but anybody else, if you need help to get on Slack, feel free to stay over, or if you have any questions, feel free to stay. And otherwise, we'll see you on Thursday. And all of the recordings will be uploaded to our course, the YouTube playlist. So if you ever want to revisit some, so we're recording it topic by topic, like the little topic. So maybe you'll be able to like navigate more easily to see which you want to rewatch to catch up. Okay. All right.
Thank you.
No problem. Y'all take care.
Thank you.
Bye.
See you on Thursday.